It is January 4th, 2015. I am attempting to show the effect of varying gain, tone, and voice on the Zen clone. Presently the gain is turned up full, tone is minimum, voice is minimum. We're feeding in a 115 millivolt signal at about 500 hertz, and it's getting a gain of about 6 to 1. The output is 725. As you can see on the blue scale, the input is the yellow scale, and it is scaled differently. The yellow, the input channel is 200 millivolts per centimeter, and the output is 500 millivolts per centimeter because the output signal is much higher. So the gain is up full, so we have maximum distortion. I'm bringing the gain down and the scale on the gain knob is from 0 to 9. We're down to 4. There's been no discernible difference. Now around 3 is 2 there. The gain is coming down, the distortion is limited, and at 0 we have practically unity gain, 115 millivolts in and 100 millivolts out, and no discernible distortion. Let's turn it up a little bit, and you can see the waves are kind of bending over to top. Now that's back up at full gain. I'm going to turn the tone control from the minimum to the maximum, and we can see that the shape of the output, there we're at maximum, has it's very symmetrical, but the tops of the signal are squashed compared to the bottom. Now I'm going to change the voice from minimum to maximum. There we are at maximum. Interesting enough, we get some phase shift, which you would not be able to hear unless you were comparing it with some other signal that was not phase shifted. And the distortion is clearly stronger on the leading edge of the waveform. Let's change the tone control. Remember, the voice is maximum, the tone is maximum. I'm going to reduce the tone. Here we get an interesting looking waveform there. Their tone is minimum. Now what I'm going to do is increase the input signal. I read on the internet that typical guitar signals are around 200 millivolts, so I'll go up to 200 millivolts. First I have to reduce it. There we are, roughly 200 millivolts. And the output did not get much higher, although the distortion may have increased somewhat. So again, I've got the gain at full. I'm reducing the gain. We start seeing an effect there around position 2 on the dial, and at 0, no distortion. So much above 2, we don't see any increase in the distortion. Let me adjust the tone. The tone is minimum. Increasing the tone, now maximum. And the voice was maximum, now we're going to minimum. And now the tone is minimum. Let's change the gain again. Nothing. Nothing. It looks like we should try to expand the gain scale. Anyway, it is producing distortion. What I would consider fairly mild distortion. Let's increase the input signal to ridiculous levels. Aha! We're not getting much increase in the output, even though the input is doubled. So, in a sense, it's kind of clipping. There we have almost a half a volt RMS on the input, and the output is up to 1.1. That's with full gain. I'm reducing the gain. There. When the gain is minimum, then the pass-through is practically without gain or loss. That's it. Let's try another frequency just for the fun of it. 2000 Hertz would probably be ridiculous, but let's go there anyway. Whoops. Yeah. We don't see much distortion at all at 2000. There, the gain is up full. I'm adjusting the tone control. Tone control has quite a bit to do at the high frequencies. Here's the voice control. Yeah, maximum voice, it turns it into almost a sawtooth. There's maximum voice and maximum tone, and there's very little distortion. Let's go back to reasonable levels on the input, 200 millivolts. Yeah. Okay. How about we go the other way, down to 200 Hertz. Okay. Again, that's maximum gain. Reducing the gain there. I don't see much effect on the gain above number 3 on the dial. This is 0. Here's half. 1. 1.5. 2. 2.5. 3. 4. 5. 6. 7, 8, 9. I'll change the tone. A little effect there. That's the voice. Okay, I'm going to stop recording.